How do we add multiple arrival processes to a SimPy model? Well, the good news is that if you know how to add one arrival process to a SimPy model, you can very quickly add multiple arrival processes. In this tutorial, we'll have a go with a very simple hypothetical hospital that provides emergency orthopedic surgery to patients suffering different types of trauma. We're going to have 4 arrival processes, one for shoulder, hip, wrist and ankle fractures. And I'm going to show you 2 ways to set your model up, and it'll be up to you how you do it in practice. Before we write our arrival processes, let's set our code up so it's nice and easy to make changes to our model. Let's import SimPy, and the first thing I'm going to do is set up some constant values. We've got some variables that represent the arrival rates for shoulder, hip and wrist ankle trauma. I've got some variables that's going to be used for setting up our sampling. So we're going to have 4 arrival processes. So we need 4 streams of pseudo-random numbers. And by default, we're going to use a seed of 0. I've also got some helper classes and functions. So the first is an exponential class. That's just a neat way of bundling up the parameters and a random seed for the exponential distribution in a reusable way. If you'd like to know more about that, I'll link to the random sampling tutorial at the top of this video. We have a small function called trace that we can use to turn our printing of the simulation run on and off, so we can see some debug values of what's going on in the simulation if we need it. That'll be very useful within this tutorial. And we have an experiment class. The experiment class is going to hold all of the parameters for our simulation model and control the random sampling. So we can see here that in an experiment, I'm passing in all of my input variables. So that first of all includes the mean inter-arrival times. All of those are going to follow an exponential distribution. And we also pass in our random number set and number of streams. The initializer for that class is pretty straightforward. We're just going to store those member variables internally, and we're going to initialize sampling and our results collection variables. In the sampling method, we're creating 4 exponential distributions and passing each of those the inter-arrival time and the random seed that's going to control the sampling. Then finally, we have a method to initialize the results collection variables. They're going to be stored in a dictionary, and in this simulation, we're just interested in the number of arrivals of different types of patients to our model. So that's the setup of our model. Now let's have a look at the functions we're going to use to generate the different types of arrival to our model. The first approach we're going to look at is where we provide a function per arrival type. So we're going to have 4 generator functions in our model. So clearly there's some redundancy in code here. Each of those functions is going to look very similar. However, it's very easy for you in a few years' time or another coder to look at this and understand exactly what you've done. So let's take a look at our shoulder arrivals generator first. So it's a standard generator. So we've defined the generator function. We're passing in the SimPy environment, and we're passing in a parameter called args, and we can see in the doc string that args is the experiment, so it contains all of the parameters for the simulation model. We've then got an infinite loop using iter tools. We're going to start at 1 and count onwards until the simulation terminates. We sample the inter-arrival time from the shoulder arrival distribution in the experiment class using the .sample method of that exponential class. We yield a timeout equal to the inter-arrival time. We record that we've got another arrival to the system of type shoulder, and we print out some debug information letting us know at what time a new shoulder patient has arrived to the system. So we then repeat that for the other types of arrival to the system. So here we have an identical function, but it's for hips. So the main differences are that for the inter-arrival time, we are sampling from the hip arrival distribution, and we're updating the number of hips trauma patients that have arrived to the system, and we'll print out that there was a hip arrival at this time. We'll repeat that for patients arriving with wrist trauma, and finally patients arriving with ankle trauma. So now we're ready to run our model. So here I've developed a single run function which will provide one replication of our simulation model with multiple types of arrival sources. So we're going to pass in the simulation experiment, we're going to pass in the replication number that we're going to run, and we'll pass in the run length. So this function is very simple. We're going to initialize all the results collection variables. We're going to set the random number set, which means we will always get a repeatable run of our model. We'll create the SimPy environment. And then rather than having a single arrival generator that we set up as a SimPy process, we're going to set all 4 of those generators up as SimPy processes. So identical code that we pass to the environment.process method. And then we run our simulation model and we return the results from the experiment. So let's have a go with that function. We'll set trace to true because we want to see some output here as patients are arriving to the system. We will create a default experiment with the default inter-arrival times. We'll run a single run of the model, return that result dictionary, and we'll print that out to the screen. So let's take a look at the output first. So here we can see there's different types of patient arriving to the system. So on the face of it, that's working correctly. We've got ankle, hip, shoulder, and wrist patients arriving. And we can see that our results are there was 9 shoulder patients, 6 hips, 16 wrists, and 7 ankles that arrived to the system. We could just check things are working right by setting the model up so that only hip fractures arrive. So this could also be a scenario where a hospital only provides surgery for hip fractures. So we'll do that by using a very, very large inter-arrival time, big M, for shoulder, wrist, and ankle patients. So when we create our experiment, we'll set that the inter-arrival time of each of those patients to 1 million, and we'll run the model. And what we see is that only 6 hip patients arrive, and for shoulders, wrists, and ankles, no patients arrive. So that model is working as expected. So in that example, we created 4 different arrival generators. Now, of course, that's not the most efficient way to code any program. So here, I'll give you an example of using a single arrival function, and we're just passing parameters to that in order to generate different types of patient. So we'll need to modify our experiment class and also the single run function in order to get this to work. So the initializer looks very similar for the experiment class. The main difference is that we now have this variable called dists. That is a Python dictionary that's going to contain keys, and those keys are going to be linked to the arrival distributions for the different types of patients. So we then need to modify the init sampling method. So we can see here now that when we create our different types of arrival distribution, all we are doing is assigning those to this dictionary dists with the key equal to the name of the trauma patient type. So here's our modified trauma generator function. So we're going to use this single function for all types of trauma patient. So now we pass in the SimPy environment and the experiment, but we also pass in a variable of type string that represents the type of patient. So that could be a shoulder patient, for example. So this looks very similar. We have our infinite loop implemented in itertools.count. But now when we sample the inter-arrival time, we look up the type of patient in the experiment dists dictionary. We yield that inter-arrival time as a delay. Then we update the patient count, and we can do that again by just appending the patient type into the dictionary for results. And then we print out, using that trauma type, the type of arrival. So our single run function looks very similar. We pass in the same variables, but now instead of having manually created those arrival generators, we're just going to loop through the experiment's distribution dictionary, pass those to an environment process method, and create an instance of that trauma generator function. So if we run that, we get the same answer as before. And again, we could just check that's working correctly. We could change the model so that only patients of type hip will arrive. So it's as simple as that. We just need to create as many arrival generators as there are types of patient arriving to the system. In this tutorial, I illustrated that with the exponential distribution, but you could of course use any distribution, including time dependency or some form of scheduled arrivals to the system. In the case of healthcare and orthopedic surgery, for example, that might be elective surgery patients. If you're new to SimPy and struggling to understand what I mean by an arrivals generator, check out this video that's on the screen now. That's going to take you through the basics of SimPy and how you can build your very first model. See you in the next video.